just looking at making the scatter plots. Today we're going to talk about the regression line that goes with it. You've done regression lines before, Algebra 1, Algebra 2. We're just going to be talking about how those lines are actually created and how to get the best possible line. So first, let's review kind of our old school methods. If I just gave you this data set and asked you to make a scatter diagram. Okay, we can do it on the calculator. If you're doing it by hand, make sure you are spacing things accordingly. So my x's go from 0 to 6. My highest y value is a 5.8. Okay, so then if we plot these, we have 0, 5.8, 2, 5.7, 3, 5.2, 2.2. Okay, so then part A, find a linear equation that relates x and y by selecting 2 points. So did I specify which 2 points to use? No, I'm just asking you to pick any 2 points on here. So let's say I did 2, 5.7, and 6, 1.9.
Where's the 1.9?
Oh, did I? Yeah, I missed one. There we go. Thank you. Right. If I pick 2 different points, will I get a different equation? If it's a true line, no. If I'm just taking 2 of these points, will I get a different equation? Yes, because this is not a perfect line by any means. So finding the equation of a line, you know you need a slope and a y-intercept. So slope y2 minus y1 over x2 minus x1. You guys all remember how to do that? Okay. So we get a negative 3.8 over 4. So negative 0.95. Now we do the plugging into y equals mx plus b. So you pick one of your points. I'll just go with the first one. My y is 5.7 equals m negative 0.95 times x, which is 2, plus b. Add your 1.9 over, and our b is 7.6. So my actual equation is y equals negative 0.95x plus 7.6. Now, is that necessarily a it's something. If I drew it, that line was connecting the points I picked 2, 5.7, and 6, 1.9. So it's not a horrible line. It kind of models the data, but it's not perfect. I just got it by picking 2 points randomly. You know, if I pick 2 different points, I get a different line. If I want to use the equation to make a prediction when x equals 3, then if I plug that in, put all that in. .75. So once you have a line or an equation, you can make predictions from that. Any questions there? A residual. This is on your formula packet. If you look, we're in chapter 4. Yesterday we talked about correlation coefficient. The column right next to it tells us your residual. So it's the difference between the observed y and the predicted y. So if you wanted to write it on your notes, I would just say residual equals observed y minus predicted y. So if I want the residual for the problem I just did when x is 3, my observed would be an actual point I saw when x was 3. So my observed y was 5.2. Minus my predicted, what did we get for our prediction?
4.75.
So if we do that, we get 0.45. Okay, so we want to come up with a better line than what we did right there. The actual least squares regression line, if you look in your book, it's a really wordy definition. But a least squares regression line just minimizes the error. Okay, you want your line to be as good as possible, so you want as little error as possible. So just to minimize that error is our goal. We use the square of the errors because error could be positive or negative. Positive if you were above, negative if you were below. So by squaring them, we eliminate that positive and negative. So to find this, the least squares regression line, this is on your formula sheet. If you look under the correlation coefficient, there's a bullet and it tells you exactly what it is. We use y hat instead of y. It's just denoting that it is the regression line. And it's just a line, so y equals mx plus b. They use slightly different error for variables. b sub 1x plus b sub 0. So to find these, the b sub 1, there's actually a formula. It's that r, the correlation coefficient from yesterday, times the standard deviation in y divided by the standard deviation in x. Your y-intercept is y bar times your slope, or minus your slope times x bar. Again, all that's on your formula sheet. You're not memorizing any of these formulas. We just have to be able to calculate. Most of the time, I will have you just using your calculator for this, but just like any of the others, I may ask you to do one by hand and then the rest on the calculator. So let's do one by hand. Do you guys have the notes written down from yesterday? We did this example yesterday. This is example 2. Can you tell me what we wrote down for all of these things? So when we did this one in our notes yesterday, what was our x bar? Y bar? 10. Standard deviation of x? Standard deviation of y? And what did we get for the r, the correlation coefficient? Okay. So from all of that, we can get our regression line. Use your formula sheet. Make sure you know how to look at these formulas and calculate it. It tells you on here your slope, that's the b sub 1. That's r times standard deviation of y divided by the standard deviation of x. So we just plug in. My r is negative 0.9456. Standard deviation of y was 5.612486. Standard deviation of x I get my slope to be a negative 2.1666. You guys get that?
Yeah.
Then we need our y-intercept, our b sub 0. Looking at your formula sheet, that's y bar minus your b sub 1 times x bar. So our y bar was 10, b sub 1 we just calculated, x bar is 4. Okay, 18.6664.
Mine's an error.
So then our equation, we write y hat equals our b sub 1, negative 2.1666, x plus b sub 0, 18.6664. right with everyone? We do have to be a little bit careful. This is like a prediction equation. So if I wanted to predict y when x was 8, all I have to do is plug in 8. What if I wanted y when x was 300? Would it necessarily be a good idea to plug 300 in here? Why? Yeah, that is significantly bigger than all of these values, right? We call that outside the scope of the model. If you have built your line around similar x values, you really need to be careful about extending it to something really far away. You know, if I were making an equation for population growth, and let's say I have an equation that models the population growth between years 2015 and 2025. Could I use that same equation to predict the population in the year 2050? Maybe, but maybe not. There's no guarantee it will still be accurate that far out. So you just want to be careful that you're only using the equation appropriately. Does that make sense? Because things can change over time. Okay, let's try doing one on the calculator. So we need to enter this. Go to your calculator and enter your data in your L1 and your L2. So now I want you to go to Stat, Calculate. We want a linear regression, number 4. You should just be able to enter through all of this. Remember, we went here yesterday when we were finding our R value. Well, this also gives us the regression line. Tells you at the top, this is y equals ax plus b. It gives you the a, it gives you the b. A is your slope, B is your y-intercept. It's the same thing we would have gotten had we worked it out by hand. We didn't turn on your diagnostics. So you have to hit second. 0. You're going to scroll all the way down to the D's until you get the diagnostic on, and then hit enter twice. Okay. So my equation then is y hat equals 3.1661x. My b's is negative 55.7966. Okay, we can graph both the scatter plot and the line of best fit just to see how good the line is. Yesterday we graphed scatter plots. If you want to graph this line along with it, all you have to do is go to your y equals and type in that line that we just wrote. So you're going to go to your y equals, and your y1 you're going to put 3.1661x minus 55.7966. Then you do need to make sure that your plot is turned on, that we're graphing a scatter plot. So remember, just like yesterday, you go to second stat plot. So second y equals. Going to plot 1. You need it turned on. The scatter plot's the first one. Then if you just hit zoom 9, it should graph your scatter plot and put the line on there. So we can see it's not a bad line. You know, we don't We have some points above and below it, but it's a fairly good line.
I'm saying air.
Okay. C. Predict the distance the golf ball will travel when hit with a club speed of 103 miles per hour. So you're just going to plug in a 103 for your x in your equation. My y is distance that was measured in yards. So it's traveling 270.3 yards. D, determine the residual. So if you forget what the residual is, remember you have the formula sheet, it tells you everything. The residual is your observed y. So if I'm looking at 103, we observed a y of 274 minus our predicted y, which is what we got from our equation. And I get a residual of 3.6883 yards. So that's the difference. My equation would have been about 3.7 yards off of what actually happened. Last question, interpret the slope and y-intercept. When I ask you to do this, I expect to see numbers and units when you're doing it. So if I am looking at this, my slope of my equation was the 3.1661, right? So the ball will travel think about your units. Slope is y over x. Well, my y was measured in yards per, my x was miles per hour. Okay, so for every mile per hour faster you hit it, it'll go an additional 3.1661 yards. The y-intercept is when x is 0, so it's kind of like your starting point. Don't start yawning. And we got a negative there. That's just like saying you're starting 55.8 yards back. That's all that it's telling us. So that's when our x is 0. Any questions for me? So that is the end of this section. Here is the homework. So a couple things. Tomorrow, I debated, but I think I'm going to go ahead and do a quiz tomorrow because I just want to see if you guys are showing a little more work. We only have one section left and then we'll be ready for our next test. So I just wanted to make sure if there's any problems, I catch them before we get to the test. So you guys know right now while we're hybrid, a quiz isn't truly a quiz. If half the people are in person, half of them are online, that's not really fair. So you can use your book or notes. You already have your formula sheet, which gives you everything. But you will turn this in then when I see you on Friday. So this book problems and this quiz will turn in Friday, and then we'll start the last section then.